Okay, welcome everyone to Practical 2. I hope you enjoyed the first practical where we kind of looked at tide gauge data that I had processed for you from NOAA, and we looked at Hurricane Sandy. Well, in this one, we're going to move to the other side of the world. We're going to look at Australia, and we are going to look at just mean sea level data. So whereas previously we looked at quite high frequency hourly data, now we're going to look at monthly means, where basically a month of data, hourly data has been, or even higher frequency data has been taken, but just a monthly mean has been calculated from that. So the tides and the storm surges are averaged out. So we've just got the sort of longer term variation. And what we're going to do is we're going to, like we went over in the lectures, we're going to split the mean sea level into three components: a kind of seasonal cycle, an intra-annual component, an interannual, a year-to-year component, and then a sort of longer-term trend. We're going to focus on Fremantle, but we're going to write the codes in such a way that you should be able to apply this to any other mean sea level record from Australia or around the world if you want. And it's always good in MATLAB to try and be forward-thinking and say, well, look, I'll write this for one site, but I'll do it in such a way that it should be easy to then change my code to work on any other site. Okay, so the first thing we're going to do is navigate to our folder. So remember, you click on the link here. We will navigate to, where am I? Current teaching, Sea Level Horizon Case Management. So we'll navigate to the practicals folder, and we should have a practical 2 in there. Okay, now at the moment this is empty. So what we're going to do is we're going to go to Practical 2 and we're going to set up 3 folders. You don't have to do this, but I always like to keep my data separate. I also like to keep my figures separate. And this time we're going to do something a bit different, but we're going to actually save the variables within MATLAB in some mat files. And again, I'll keep those separate. So my code is going to sit here, but my data and everything will be separate, just so it's sort of nice and organized. Okay, the next thing we are going to do is, well, I'm going to go to Safari, you can go to another web browser, and we're going to go on to the Permanent Service for Mean Sea Level site. I've been on it so often that it just appears, but it's psmsl.org. And you're going to, by all means, have a look around this site, but you're going to click on this table tab here, and down the bottom is a table. And what I tend to do is I sort it by station name, and we're going to scroll down to Fremantle, A, B, C, D, E, F. You can tell I'm dyslexic. Fremantle here. And it should be site 111, so we're going to click on that. And this is the site here, so you can get information about the lat and long. You can see the monthly data. You can click on this plot. But what I'm going to do is I'm going to right-click on the download monthly file, and I'm going to download the linked file. And we'll go into Practical 2, data, and I'm going to save it. And it should be 111.rlr data. So we're going to save it there. Okay. And then we're going to come back to MATLAB and we're going to make a start. So we're going to do a new script like we always do. I tend to always have the same sort of way I work in MATLAB, so but you can embed this within the screen if you want. Okay, and I'm going to avoid long, complicated names. I'm always just going to call them control. So let's start with a control 1. And again, always very good at practice. I'm going to write my name at the top. I'm going to put the, sorry, my mouse has frozen, just give that a second. I'm going to put the date. I'm doing this in January, but you'll be looking at this in February. And then I put a description about this M file. This M file loads in PSMSL tide gauge. PSML, let's just put PSML, so that's data for one site, and separates monthly mean sea levels into a seasonal, inter-annual, and longer term trend component. Now I always just put some funny lines just to kind of break my code up, and I always as well put clear comma just for and CLC. That just clears the screen, and it clears it clears all the variables from the workspace, and it clears the command window. Okay, now let's have a look at our data. So I'm going to go back here, and you can just drop this into a text editor, and let's have a look at the data. Okay, and you can see the data format is actually quite simple. We have the decimal year, then we have the sea level, and this is in millimeters, and then we have two other columns here. This is the number of days in a month when there's missing data. So this particular month there was 9, and this is whether you should use the data set or not. And there's you can go into the Permanent Service website. There's a link in the step-by-step guides, and it will tell you about this format. Have a look here, and you can see there's some default values that we'll clearly need to remove later. Okay, so again, let's always write in code in blocks. So double %, step 1 is load in data. Okay, and again, because this file is nice and simple, we can just use the load function. But before we do that, let's create a file in. A file name always is single quotes because it's a string. So we want to go into data, and we want to come back here and just copy and paste this name. And that's the file in there. And then we can write a function to load this data in. Remember, function is always square brackets for the outputs, the function name, circular brackets, and file in. So let's run all of that code and see what happens. We can double click on D and bring it up in the workspace, and you can see those 4 columns of data there. Now there's a slight issue here in that this is what's called hard coding, and I want to not hard code this so that in the future all the PSML sites have the same format, but this number changes. So I'm actually going to take that number out. And how I'm going to do that is actually add 3 strings together. So let's say, for example, I had A is Ivan, let's put a space on the end, B is my wife's name, Fiona, and C is my daughter, Ren. I can add those those 3 together using a square brackets, and you can see I now have this variable called D, which is those added together. So what I'm going to do here is add the folder name, then I'm going to add this number, and I'm going to put it as SID, which in my mind stands for site ID, so that I can change this when I download some new data and just run it through. So let's just check that works, and yes, that works well. So you can see it's loaded in the data again. So down the line, you'll see we'll just be able to change this one number, and we'll be able to run this essentially for any site. Okay, now I'm going to separate it into the variables. We don't have to do this, we could just work with D, but I think when you're learning MATLAB, it's easier to separate it out into variables. So we're going to have the year month, the kind of decimal year month, which is D. Remember, it's all the rows, the first numbers are rows, column 1, and then I use cut and paste a lot, and then we're going to do RMSL, and that to me stands for raw mean sea level or relative mean sea level, because it's got land movements included. And then I'm going to get rid of D. I like to get rid of the variables, so I'm kind of left here in the workspace with just the ones I want. We could get rid of SID, but I'm not going to, because I'm going to use that later. Okay, so now we have the 2 variables. Now remember, we had that negative 999 there, so I want to get rid of the, I think it was negative 99999 values. And this is, I use this function all the time in MATLAB. It's one of the functions I use the most, but it's the find function. So I'm going to say I is find, and I'm going to say RMSL. There is only one column, so I don't really need to put that, is equal to, and use the double equal to signs whenever you're using a find function, just to separate it out from here. So this is going to find, and let's run it and you'll see, but it's going to find all the row numbers. So it's going to say row 15 and row 34 have those 999. So we can go into we can go into the Army scene and check this. So scroll down, and you can see, sure enough, row 15, and if we get down to row 34. Okay, and then the next thing I'm going to do is relative mean sea level, just row I, all the columns. So this is going to be row 34, row 15, row 34, etc. And I'm just going to say is NaN, and then I'm going to clear I. NaN stands for not a number. And you can see this is quite nice when it comes to plotting. So if we go to row 15, it's replaced that with not a number. Okay, the next step we can do is plot the data. So let's do another line of code. Plot the monthly mean sea level values. Okay, now this time, rather than just using the word figure, which brings up, let me run that, a small figure, I actually want my figure to be a bit bigger. And there's other properties you can set, and one of them is units. I'm going to set normalized, it's American spelling with the D, and then the word position. And I'll explain what this means in a second. Okay, the units is the kind of units of the screen. Now most screens are in pixels, but if you go to normalized, it means that this bottom corner is 0, 0, this top corner is 1, 1. And then the position has 4 numbers. The first number is I want to go 10% along. Second number is 10% up, so my figure will start somewhere here, and then my figure is going to be 50% take up the width of the screen in length, 50% take up the screen. Now these seem a bit random, but you'll soon get used to them. And then I'm going to use the subplot function, which we talked about last time. So the number of rows, I'm going to have 4 rows of figures, 1 column, and this is going to be figure 1. And then let's plot the data. So now we can hold on. I always just put hold on by, even if I'm only plotting one thing, just because I might decide later. Let's plot this as black. But again, with all MATLAB functions, there's often other things you can add on. So here I'm actually going to put the line width to 2 rather than 1, just to make it stand out. So let's run that. Load in the data. You can see my figure's now a bit bigger than normal, and there you can see my subplot. Now, as always, I add lots of things on here to make it look better. And you can, once you've done it once, you can just often cut and paste. So my Y label is going to be level, millimeters. And again, you can add in other properties here. So I'm going to set my font weight as bold, my font size as 18. You can change the color and everything if you want. So once you get good at this, there's nothing you can't really do or change. I'm going to turn the box on. I'm going to put a grid on. I am going to put a title. Again, I cut and paste. I'll make the title a bit bigger. So my title is going to be A, and this is going to be relative or raw, it doesn't really matter, mean sea level. And then I like to do this, but I set the axis, so this A1, I always like to set it to be a bit bigger. I always think when you save figures and export them to report, it always looks nice. So I typically set this as 16, and you'll see it'll make the axis bigger. And then I'm going to set A1, the X lim. And I'll show you this A1 in a minute. So I'm going to set this as the first year, which is 1897, and I'm going to go to 2020. So let's run that selection. So now you can see my figure looks a lot better. The labels are bigger. It just looks a lot better. If you go into A1 here, you can say get A1, and again it tells you all of the properties that you can set associated with this figure. My MATLAB's running a bit slow today for some reason, so let's just give that a second. So these are, you can set the labels, you can set the colors, you can set where the ticks are, you can even rotate the text. So we'll come back to that later. So let's leave that figure up there. Okay, now we are going to separate sea level into its 3 component parts: the seasonal component, a year-to-year component, a long-term trend. Now, to do this, we actually need to work backwards. We first of all need to calculate the long-term trend, remove this, then calculate the interannual component, remove this, and it leaves us with the seasonal cycle. Now, for the long-term trend, there's lots of different ways we can do this, but I'm going to start quite simple, just with a linear trend, a polynomial. So that has a form y equals ax plus b, where a is the gradient, b is the intercept, and I've gone over this in the step-by-step guide. So let's now separate out the longer term component. Okay, so let's calculate a linear trend to start with. So now when we use the linear trend, we're going to use the polynomial function. So I'm going to say t is polyfit. And again, if you don't know how these work, you know, just type help polyfit here, or into the or type on the help menu there, and it will kind of tell you how polyfit works. But essentially with polyfit, we need the year, we need what's on the x-axis, the year, and what's on the y-axis. Now, if we were to run polyfit here, it wouldn't work, and that's because there's not numbers in there. So we actually need to remove those not numbers. So I'm going to use the find function as well to find the row numbers. Now here you can use this funny little squiggle sign, and that kind of means not. And then I can use a function called isnan. Relative mean sea level, shift column 1. So what I've said here is find within the RMSLs function all of the values that are not NANs. And if we run that, you'll see it will find all of the row numbers that are not NANs. And then we can put those row numbers into, so we can fit this polyfit just to the row numbers when there is not NANs. And then I've missed the last thing at the end. We need to define the polynomial order. So a 1 is just a linear fit. If I was to do a 2 there, which I'll do later in this practical, it's a quadratic fit. But a 1 is just a linear fit. So we can run this, and we can get t, and those are the two variables. So that's the gradient. This is rising at 1.68 millimeters per year, and this is the intercept. And now what we can do is we can say linear means sea level, and we can use the polyval function to actually fit a line. So we need the parameters t, and then we need a variable, and it could be ym, the x-axis. So this will now fit a line. And we can plot that, and I'm actually going to plot that on in fact, I'm going to cut and paste this. And I'm going to change it. So here I'm actually going to plot it on the bottom axis, the A4. So this becomes 4. I need to just make sure I change A4 here. Now this is going to be D. It's going to be the long-term linear trend. I noticed I've got a spelling mistake in there, so let's just correct that. It's a long-term linear trend. And here I'm going to plot YM, but against this LMSL, which is the linear trend. I'm going to use, now because this is the bottom plot, I'm going to add a Y label. I don't bother with Y label, sorry, an X label. Don't bother with them all, just the bottom one, because then it sort of interferes with the title. So let's run that code, and it should add it on to the end. Okay, so I've got it should be polyval. So again, you can see here that there's no function. So once you get good, you start to recognize the errors there. And this one, let's just run that one again. This one I'm going to plot as a green line. Now, I don't like this horrible MATLAB green, so I'm actually going to set up my own green. And MATLAB has this 3-digit color system where it's the amount of red, the amount of green in percentage, so that's 0%, 100%, and then 0.3. And there you can see the kind of linear trend. Okay, so there we separated out the first component. Okay, next we are going to calculate the interannual component. So what number are we up to? We're number 4. So now separate out the year-to-year or the interannual variability component. Okay, now to do this, I'm just going to run a smooth at 12 months, so kind of 1 year smooth through this data, which I know in experience works well. So let's smooth the data by a 12-month running mean. Okay, so I'm going to call this IMSL for interannual mean sea level, and I'm going to use the move. What is it? The move. I don't think you need on the end. The move mean function. So what I want to move mean is the raw mean sea level, but I'm going to subtract the long-term trend, so the LMSN in there, and I'm going to do it by 12 months. Now I just need to add something at the end. Because this data has NANs, I'm going to admit NAN, and if you looked up this move mean function, you could see there was that option at the end. And then I'm going to plot this. So again, just make the most of your cut and pasting. I'll change this to 3, change that to 3, that to 3. Now here I'm going to plot the interannual component. I can take this color out and I'm going to plot this as blue. I don't need an X label. And this is going to be C. I'm going to plot this in the C component. And this will be my interannual or year-to-year component, interannual component plot. So we can run that. And there you go. You can see the kind of year-to-year. So you can see there's a big drop there. That might be due to some bad data or some missing data. You can see there's an interesting feature here, which is actually, later on I'll show you, is very strongly related to ENSO. Okay, let's just clear the window there. Okay, so we're getting on well. We're almost finished with this component. And now we can do, finally, the seasonal component. So 5 is the seasonal component, or separate out the seasonal component. Now the seasonal component is quite easy to do. So seasonal means sea level. All we do is we take the relative mean sea level, we remove the interannual mean sea level component, and we remove the long-term trend. So that's it there. And then we can plot this. This is now going to be 2. So you can see I'm having to work backwards here, but that's fine. Now this is going to be seasonal mean sea level, and let's plot this as red. This is going to be A. This is going to be the intra-annual, the seasonal component. Let's check I've done that rightly. And there you go. So this complicated signal here is made up of this kind of seasonal cycle, which we'll look at in a minute, the interannual component, which we'll look at in more detail after that, and the longer term trend. Okay, so we've done very good there. So we've just got one final step. What I'm going to do is, rather than loading in this data and having to do this every time, I'm actually going to save this to what's called a MATLAB file. And a MATLAB file just saves these kind of variables as they are. Now again, I want this to be generic and to work on lots of things. So I'm actually going to create a file out name. And the file out name, I can borrow this code up here because it's going to be quite similar, and I'll edit it. It's going to be, I'm going to save it into the mat files folder. I'm going to save it by the site ID, so 111, and it's just going to be a mat file. And then what we do is we just use the save function. The first input is the file out, and then we can just save the variables that we want. So I don't want all of the variables that are created, I just want ym, I want the raw mean sea level, I want the seasonal mean sea level, I want the interannual mean sea level, and then I want the longer term mean sea level component. So I just want those 3. So let's just close this down, let's run everything again. You can see that's run, and now if we go into our map files here, we can see it's created a file. So from now on, we can just call that and it will get the variables we want. Okay, we'll finish this component there and I'll do the other ones in subsequent videos.